Hi there, today we're going to do application problems using polynomial functions. This problem here is probably one of my favorites because as you can read here, the only information they give you numerically is 18 feet of fencing. Okay, so we have a couple of homeowners want to build a garden up against the back of their house. To keep out their small dog Jenkins, they need to surround their garden with some type of border fence. They only have enough money to buy 18 feet of fencing. What dimensions should they make their garden in order to maximize the amount of gardening space? Okay, so as I said earlier, they only give you 18 feet of fencing. That's all the numerical information they give you. But can you think of something else that is important in this problem? This piece right here. Build a garden up against the back of their house. This is important because if you imagine here's a house and we are building a garden that we have to fence. One of the sides is the wall of the house, so we only need three sides of the fencing. Okay, and the question says what dimensions should they use to maximize the amount of gardening space? Okay, there's a couple things going on here. All they give you was that you have 18 feet of fencing. That's all you know. Okay, so if you can imagine you have 18 feet of fencing, whatever it is, wire, um, maybe some fencing material, that's 18 feet. Well, that's going to wrap around the fence. What is that called when you have the border to be in geometry? What is that called? The perimeter. So all you know is that the perimeter is 18 feet. Nothing else. You don't know anything about the dimensions. You do, however, know that the width is the same on both sides and you only have one length. So um, that's what we know. We know that the perimeter is 18 feet. What we want is to maximize the amount of gardening space. What does that mean, the amount of gardening space? Well, that would be the inside. So we're referring to the area. So you want to maximize the area. So there's two things going on here. You know the perimeter, but I want the area. You are used to looking at a problem and all the information is given to you in that one problem. Here there's two things going on. You have the perimeter, but I want the area. So what we're going to do is we're going to create an equation for the perimeter and use that to find the area. Okay? So let's create an equation for the perimeter. Well, if I add up all these sides, I would have W plus L plus W. That would be 2W plus L. And remember, that is 18 feet of fencing. Again, this is what we know. You don't need that feet, by the way. Just 18 equals 2WL. This is what we know, but what we want is the area. What's the formula to the area of a rectangle? Length times width. Okay, the problem is when you have a function, in this case you have a function in terms of L and W, you have a function for the area. When you have two missing variables, you can't solve this. Well, lucky for us, we have another equation that we came up with that will help us solve the area. So what I'm going to do is I'm going to use my perimeter equation, substitute it into the area equation, so that you only have one letter. Which letter would be the best to solve for? L would. When you solve for L, you would subtract 2W to both sides, and you get L equals 18 minus 2W. So I'm going to substitute 18 minus 2W for L into the equation of the area. Okay, so I have area equals 18 minus 2W times W. When you distribute this, you will notice that you end up with a quadratic equation. So I'm going to go ahead and write this in standard form. Alright, so now we have an equation for area in terms of the width. Well, let's not forget our goal here is to maximize the area. Well, you've heard that word before, maximize or maximum. Where have you heard that before? Well, when we talked about parabolas, we talked about the maximum of the parabola. What is it referring to? The vertex. How can I find the vertex of this problem? Well, if I rewrite it in vertex form, if you remember vertex form, it's easier to find the vertex. How do I write it in vertex form? You have to complete the square. Alright, so let's go ahead and complete the square. There's nothing to push to the side, but remember you have to factor out a -2 so that you can half and square the 9. So half of -9 is 4.5 negative, but when you square it, you should get a positive. Go ahead and work that out. 20.25. Remember you have to balance, so you subtract 20.25. And because you factored out a -2 the beginning, you're going to multiply that by -2 on the outside there. Okay, clean this up. I have the area equals -2 times W minus 4.5 squared. When you multiply -20.25 times -2, we get 40.5. Okay, so great. Now we found the vertex form, but what was the point of that? Why did we put in vertex form? Well, to find the vertex. So the vertex is 4.5 and 40.5, but what do those numbers even mean? If you go back, the question says, what dimensions should they make, or what dimensions should they make their garden in order to maximize the amount of gardening space? Well, if this is a function for the area in terms of W, that means that the area is your Y value and the width is your X value. So the width is 4.5. The maximum area is 40.5 square feet. But what's the length? Well, you can go back to the original problem for the perimeter and you will find that it's 9. Okay, so this is what we did Wednesday, October 30th. Go ahead and take that as notes so that you have some application problems. Friday, I'm giving them a test for sections 2.1 to 2.5. So please review that. I hope you took your books so that you can study that when you come back. You could take your test. Okay? Have a good one.